Hello, everyone. How are you doing? Yeah. So I'm very excited to be here tonight because this is my second. This is my second talk abroad in person in English. So yeah, I'm very excited to be here. Is it better now? Maybe the microphone. Okay. So who here knows what is refactoring? Everybody does refactoring daily. Do you like to do refactoring? Do you like to do? Yeah. The others, not so much. Okay. Three guys really like to do refactoring, so this maybe is not for you. It's too simple. It's for the other guys maybe. But yeah, my talk is refactor today, build faster tomorrow. Because when we have cleaner code, it's very easy for you to focus on the other things that you really like to do. So if you don't like to do refactoring, maybe you need to do refactoring so you can save time to do other things like new features or maybe experimenting on new technology. So I lost my slides. Okay. So let's start with a chaos checklist. Who here ever saw variables and methods with meaningless names? You see the method name and you don't have a clue what it does, okay? More than one responsibility in methods classes. That is classic, okay? Too many comments to explain the code. Okay, a pause here. Who likes to write comments? Yeah, I know people that really enjoy writing lots of comments in the code. Classes with more than 1,000 lines. No, never, right? Who here is a Java developer? No? Other languages like maybe Python? Yeah? C#? No? What language do you use? No? Ruby? Okay. So we maybe have this problem whenever language, right? But it's very common that you see like Java classes with more than 1,000 lines. I can't say details, but I saw one classes with 11,000 lines one time. Yeah. Methods so large that they don't fit on the screen. Yeah. So do you like to use that monitor like ultra wide? But some people use that way, so you can fit the method in the entire screen, right? Yeah, I know some guys. Frequent use of copy and paste. We never do that, right? No. And changing a piece of code and discovering that it's duplicated in another method or class. Yes, the other day I had to fix a bug. I fixed it. It went to production. And 2 days after, 2 days, they had another problem, the same bug. And the guy from, what can I say, like the business side of the project, the people that are using the project, the product, they said, I thought you had fixed that bug, but I discovered that the same code was duplicated in other 5 classes. So now, whenever I fix a bug, I use lots of regex to find similar code and fix all the bugs in other classes. So if you are used to see all that kinds of things in your code, maybe you are the guy that deploys on Friday. So it gets more excited with all these cases, right? Okay, so you find a code that is very, very ugly, lots of code smells, and you want to know who was the guy responsible for that, and you discover that it was yourself. It is very common, again, to happen. But what is refactoring? So Martin Fowler says that refactoring is restructuring existing code without changing its observable behavior. So talking about behavior preservation, what is it? So preserve behavior for readable, sustainable code. No alteration of existing correctly functioning code if it's functioning correctly. That's important because maybe if you're fixing a bug and you need to refactor that code where the bug is located, maybe it's not functioning. But the refactoring principle says that, the preservation principle actually, says that you don't want to alter the functionality, right? So refactoring phases using tests to prevent breakage. This is very important. When we are, I see that 3 people that really like to do refactoring, you know, when you like to do refactoring, you get a very long class and you want to refactor it entirely. And when you go to the test, nothing works anymore. So the principle says that you need to refactor in phases with tests to prevent it. So why refactoring? Now that we know what is refactoring, now that I see that lots of people here likes or needs to do refactoring every day, why refactoring? The first thing, to improve readability and maintainability. So it's it's easier to maintain, to fix other bugs if you refactor every day. If you get a clean code, it's very easy for you to understand what that code means, what it wants to do, so improve readability and maintainability. So it's easy to add new team members. When someone enters your team, I had some problems in the past because I had lots of new features to do and to deliver. And I didn't have the time to train the new guy. So if the code is easy to read, the new guy on the team will not ask you all the time, what this do, what is the purpose of this class, and stuff like that. But don't use comments to do that, okay? The code has to be clean enough for people understand what it does. So why refactoring? To reduce technical debt. What is technical debt? It's something that we do now that we need to correct in the future, or something we don't do now and you need to correct in the future, like we don't update a library right away, and then when you need to update the library, it's a version that is completely different and you need to change lots of codes. So that's technical debt. So if you reduce technical debt by doing refactoring, it allows new tech to be implemented in an easier way. So to facilitate feature modifications, modernization, migration, of course, to improve performance. Have you heard that only by changing the JVM, like for example, from Java 23 to 24, you can get like 30% of performance. Yeah, a better performance. So in some cases. So yeah, refactoring is good for performance as well. And like to update Java versions. In the company that I'm working right now, we develop system for a big university in Brazil. And we have like big, extremely big academic systems there. Like we have 83 projects in Java right now. And lots of these projects are in Java 6, Java 7, Java 8. Somewhere Java are using Java 17 or 21. And now we're talking about 25, the new LTS version. But the problem is, if you have like lots of technical debts, like in these projects that I'm talking to you, you can't update the Java version. It's very difficult to do that. So that's why refactoring is, right? It's a good thing. So to free your time to focus on your features. So if you don't like, if you're not the 3 guys that really like to do refactoring, maybe you can do refactoring to free your time to focus on what you really like to do, okay? So, and last but not least, when refactoring. So what it is, why and when. Why I create this slide? Because in my company, some developers were doing refactoring just to add lots of issues. Because the number of issues is something that we use to track the developer performance. So they are doing like small refactorings and creating lots of issues for that. So refactor, if it's not something that it's in your project, like we need to refactor, this is an issue, this is a task, you don't create lots of text for do this. You, when you are adding new features, you go there and you refactor. When you're fixing bugs, you refactor. When you make small adjustment, when you're adopting a new Java feature, then you go there and refactor, right? It's not new tasks. So we're talking lots about AI these days, right? And you can use AI to do refactoring. And the other day I saw this real case of using AI to refactoring, and the guy said, Cloud 4 just refactored my entire code base in one call, 25 tool invocations, 3,000 plus lines, new lines, 12 brand new files, modularized everything, broke up monoliths, that's what we need to do, cleaned up spaghetti, none of it worked, but boy, was it beautiful. So yeah, but yes, we can use AI. There are lots of good tools for that. I don't know if which IDE do you use, but like IntelliJ has good tools, VS Code as well, and you can use Claude as well. But don't ask the agentic mode to refactor your entire code base, please. So a disclaimer here, refactoring is a skill. So it's something that you need to acquire, and that requires time. But I try to bring here 10 simple ways of refactoring, 10 simple things that you can do right away, so you can put it into practice today. So, and refactoring does not require a lot of work. If you don't like refactoring, okay, but it's not a lot of work. You can think about legacy code and you think it's a lot of work, but no. You will see that once you acquire the skill, refactoring is natural. Whenever you start writing some code, you will remember the techniques, you will remember to write clean code, and it becomes natural, okay? So let's do it. I told you 10 simple techniques or principles for refactoring. The first one, renaming methods. It was the first item on the chaos list, right? So renaming methods, it's very simple, but here is a real situation for my work. So sorry if I have some Portuguese words, but yeah, this method is like it's from a diploma system. So it's a filter for editions of some specific diploma, and you have like the type of the filter, the key that you're using to look for, to search that diploma specifically. But then you have DM. So I'm working in this project for at least 4 years, and I didn't know what was DM. So when you use like instead of the entire word, use just the first word, the first letter. Maybe when a new guy enter in your team, they will not know what DM refers to, right? So it's like manual diploma, and I found out later. So manual diploma, in Portuguese diploma manual, I just renamed the methods. So now anyone that knows this context will know what the method tried to do. But then I found out the other method. This was the original name. And yeah, I don't have a clue. Now I know that is a manual diploma, but that may be a date and mayor is like greater than that date. So I found out that that date was the date that the new system was alive in 2011. So whenever you try to find a diploma starting from this date, it searches in the new database. So in this case, I didn't knew how to rename the method. So I created a Java doc explaining what the methods was trying to do. Okay? So the second one, extract methods and classes. It's fundamental for creating components with new features. So to begin with, a problem. The problem is you have like a code fragment that can be grouped together, like that one. You have the name and the amount. You can extract in another method here. And you can reuse that method whenever you want to print the details of the account, right? The third one, introduce a new variable. So do you know what is a magic number? What is a magic number?
Have in the code a value you have in the code that.
And you don't know what it means. So for example, you have like convert to hours, and you know that 3600 is the number of seconds within an hour, but maybe it's not okay. It's not a common knowledge. You have to think a little bit about it. So instead of using a magic number, you introduce a new variable that has a meaning, like this constant, seconds in hour. And whenever you need to use that same number, you use the constant. Okay? Again, it's too simple, but sometimes we forget to do this kind of thing because we know what the number means. You just use the number. But this happens with other things as well, not just numbers. Extract variable. We have a problem. You have an expression that's hard to understand. The solution. Place the result of the expression in a new variable. For example, you have conditions inside an if statement. You have like age greater equals than 18, and male equals gender, and client equals category. So you can create a new variable that consolidates all of the conditions that you can consolidate, like is male client, male and client, and then the age can be other thing, another variable, another condition. Okay. 5. So pull-up field. Pull-up field is when we have like the same field here in classes, and you can use the same field in the superclass. So you don't need to have lots of methods. You don't need to declare the method in each of the classes. Okay, and the same happens in the 6th here, that is push down field. In this example, you have the superclass employee, and the other classes are salesman and engineer. And maybe the engineer, they don't receive like the tips or something like that, like get quota, like the salesman. The 7th one is use functional programming. Who here likes to use functional programming? You're using daily, yes? So if you use lambdas, if you use string, you're using functional programming in Java. Like lambda expressions, they enable functional programming in Java. And we have here 2 switches. The first one is a switch statement that is the most common switch template in Java, right? And we have a switch expression. Which one do you like more? Sometimes when you use functional programming, the code is not easier to understand, but sometimes it is. In this case, when you use optional, maybe it's harder to understand. Okay? No? You don't agree? Maybe yes, in some cases, maybe not. But yeah, so if you use functional programming whenever you need, whenever you can, this may be, you can refactor to have a cleaner code, a code that is easier to understand. And less lines, right? Less numbers of lines. And now to finish, I said that was 10, right? So the 8, 9, and 10 are not techniques, are principles. The first one is dry. Don't repeat yourself. Have you heard of this principle? It's very famous, quite famous. Is maybe the most important principle in the OOP, right? So don't repeat yourself. It means that every piece of knowledge or logic in your code should exist only in one place. So if you find yourself using copy and paste, like I said in the chaos list, that's sign that you're breaking the dry principle. So by following dry, your code becomes easier to maintain because you have the code in only one place, and when you need to update it or maybe fix some bugs, like I said in the beginning, you just need to fix in one place. Otherwise, you have like that Spider-Man meme from the multiverse. So I have a small example here, but sorry, some words are in Portuguese, but we have like the salary bonus and a calculation of the salary plus the bonus, and you print the information there. And this is classic when you're starting to use Java and you don't know about OOP and start like programming like procedural languages. But then you can extract methods, extract variables, and you reuse the code. Thus, the second principle of the three last ones are keep it simple, stupid. Have you heard of it? Yes, this is a very good principle. There is a gentle version that is keep it simple and straightforward. Okay, so in Portuguese in Brazil we have also a gentle version, but okay. It's a reminder that simple solutions are usually better than complex ones, and it's very easy. It's better if you have a simple code, if you need to maintain, if you need to fix some bugs. So don't over-engineer. Write code that's easy to read, understand, and maintain, not only for you, but for the others, for other team members as well, okay? And it's not the band, it's the principle, okay? And the last one, okay, we have some examples here. So it's why I need all of these lines of code just to check if the number is even. So I don't need the if and else. I don't need here, if you know the module, you don't need to return true, else return false. You just need to return the result of the module, right? So you can rewrite the same thing in a simpler way. And one question here. Which one of you use this kind of thing? It's like ternary, yeah? Do you like to use it? So there is a discussion, people from clean code. There are people that think this is not simple. There are people that think it is. I think depends on the size of your statement, right? Okay, so it depends, always. Another example of the keys principle, when we need to work with code blocks like this, you have to write a string that is actually an SQL, JSON file, something like that. You needed to escape all the special characters. But with text blocks, you just need to write as it is, okay? So this is a feature that is on Java for quite some time. But maybe sometimes we forget to see the new features. Like we have Java 25 right now, and maybe you need to get sometimes to learn the new features and incorporate some of it in your refactoring, okay? So the last one is Yagni, you aren't gonna need it. So it means Don't build something until it's actually needed. Lots of times we think we need something and we enter lots of to-dos in our code, right? That's not a good practice. If you think about refactoring, if you think about Yagni, if it's a feature that you really need, maybe you just go there and create the feature. If it's not, if you don't need it right away, don't create a to-do. Talk with the project members so they can create the feature in the right time. So remove unnecessary comments. That's another thing. If you like to write lots of comments, right? Remove unnecessary comments. Use clear code and Javadoc instead. If your code is straightforward, if you read the code and you know it knows exactly what it's doing, you don't need to create lots of comments. Otherwise, you have this situation. You have a stop sign, another sign saying this is a stop sign. You don't need it. So think about that sign whenever you are writing a new comment in your code, okay? Okay, I have some examples here. This is another real code from my company. We have like this comment, use web services in the future. But then if you see the next line, graduação service, WS, web services. It's using web services. Someone changed the method and left it to do there. So that's why it's not good if you enter lots of codes. Okay, my time is up. So the last one here, so don't create to-dos. This guy created the method, but without implementing it. And the last one, the Javadoc. Javadoc is a good comment. If you create a Javadoc, it's a good practice. You just explain what it needs to be explained. Okay? So to conclude here, 2 statements. The first one, scout rule. Always leave the campground cleaner than you found it. The same principle applies to our code. Whenever you are fixing a bug or creating a new feature, try to refactor it and leave a better code. It's from this Uncle Bob, from this book. And the last one is, any fool can write code that a computer can understand. Good programmers write code that humans can understand. Or maybe the AI can understand, and it can help you to refactor and not break all your code base. And Martin Fowler say that, and he has this book on refactoring. Okay, so thank you so much. If you have some questions, maybe 1 or 2 questions. Anyone? So while you ask me some questions, you can connect with me. And I have some good material on refactoring. If you want to go deeper in this subject, you can ping me on LinkedIn and I send you all the material that I have, okay? We have some AI material from Loiane, Bruno Borges, and yeah, that's it. Okay, thank you. No questions.